Andrea and welcome to my Geo vlog. Do you know what is fault?
In geology, faults is a planar or gently curved fracture in the rocks of Earth's crust where compressional or tensional forces cause relative displacement of the rocks on the opposite sides of the fracture. Faults range in length from a few centimeters to many hundreds of kilometers, and displacement likewise may range from less than a centimeter to several hundred kilometers along the fracture surface. In some instances, the movement is distributed over a fault zone composed of many individual faults that occupy a belt hundreds of meters wide. The geographic distribution of faults varies. Some large areas have almost none, others are cut by innumerable faults.
Do you know that there are types of fault?
Deep slip faults are inclined fractures where the blocks have mostly shifted vertically. If the rock mass above an inclined fault moves down, the fault is termed normal, whereas if the rock above the fault moves up, the fault is termed reversed. A thrust fault is a reversed fault with a dip of 45 degrees or less. Normal deep slip faults are produced by vertical compression as Earth's crust lengthens. The hanging wall slides down relative to the footwall. Normal faults are common. They bound many of the mountain ranges of the world and many of the rift valleys found along spreading margins of tectonic plates. Rift valleys are formed by the sliding of the hanging walls downward many thousands of meters, where they then become the valley floors. Reversed deep slip faults result from horizontal compressional forces caused by a shortening or contraction of Earth's crust. The hanging wall moves up and over the footwall. A reversed deep slip fault is the opposite of a normal deep slip fault. In this situation, the hanging wall moves up relative to the footwall. Reverse faults indicate compressive shortening of the crust. Thrust fault is a break in the Earth's crust across which older rocks are pushed above younger rocks. Thrust faults earthquakes generally occur when two slabs of rock press against one another, and pressure overcomes the friction holding them in place. It has long been assumed that at shallow depths, the plates would just slide against one another for a short distance without opening. Thrust faults have been the site of some of the world's largest quakes, such as the 2011 Tohoku earthquake off the coast of Japan, which damaged the Fukushima nuclear power plant. They occur in weak areas of the Earth's crust where one slab of rock compresses against another, sliding up and over it during an earthquake. For strike-slip faults, the failure surface is usually near vertical and the direction of movement only occurs laterally with no or very little vertical motion. Strike-slip faults with left lateral motion are known as sinistral faults, and those with right lateral motion are known as dextral faults. Each is defined by the direction of movement of the ground on the opposite side of the fault from an observer. Strike-slip fault, also called as transcurrent wrench or lateral, are similarly caused by horizontal compression, but they release their energy by rock displacement in a horizontal direction, almost parallel to the compressional force. The fault plane is essentially vertical, and the relative slip is lateral along the plane. These faults are widespread. Many are found at the boundary between obliquely converging oceanic and continental tectonic plates. Well-known terrestrial examples include the San Andreas Fault, which during the San Francisco earthquake of 1906 had a maximum movement of 6 meters or 20 feet, and the Anatolian Fault, which during the Izmit earthquake of 1999 moved more than 2.5 meters or 8.1 feet. So next is the oblique slip faults. Oblique slip faults have simultaneous displacement up or down the dip and along the strike. The displacement of the blocks on the opposite sides of the fault plane usually is measured in relation to sedimentary strata or other stratigraphic markers, such as veins and dikes. The movement along a fault may be rotational with the offset blocks rotating relative to one another. This fault has a component of deep slip and a component of strike slip movement, and it is termed as an oblique slip fault. Nearly all faults will have some component of both deep slip and strike slip, so a fault that is classified as oblique requires both deep and strike components to be significant and measurable. So what is the importance of knowing the faults in terms of engineering? When such porous and fractured zones get saturated with water, their strength comes down further. The same fractures act as channelways for movement of groundwater. This may cause severe groundwater problems in case of tunnels and leakage problems and in case of reservoir. The most dangerous feature is its possible recurrence at the same place. This means that the fault ground are unstable as long as faulting remains active there. Generally, faults are accompanied by earthquakes. Earthquakes cause severe shaking of the groundwater. Such shaking may cause collapse of civil engineering structures like buildings. The fault plane itself is a very prominent fracture plane in the fault zone and therefore may act as severe sources of leakage of water. Such weathering further reduces the competence of the rocks. Fault influences the movement of surface water also. To some cases where the deep direction of the fault plane and the surface slope occur in the same direction, landslides may occur. Engineering geology is a very important topic for structural engineers to understand as it helps them properly plan a project when considering the design, location, and other important geological factors. Engineering geology helps ensure a safe and cost-effective design for construction projects. So what will happen if the engineers do not know that there is an active fault beneath the constructed building? So for example, this is the land and this is the fault and this is the constructed building. So what will happen to the building if there is an active fault beneath and the earthquake occurs? Simply, the building will collapse. So therefore, the engineers must study before they construct a building because there might be an active fault beneath the land. That's where the geodetic engineer came.
That's all for today. See you next time.